Hello students, today I am going to tell you about the experiment. It is to prepare the true solution of common salt, sugar and alum in water. Second is to prepare a suspension of soil, chalk powder or fine sand in water. And the third is to prepare the colloidal solution of starch in water. And we will differentiate the three different types of solution on the basis of their transparency, their filtration criteria and the last is stability. So look at here, we are having some chemicals. We require some test tubes for the experiment. The first one is the salt. This is a common salt. Second is the sugar solution. This is sugar solution. And the next is alum. These three chemicals are required to prepare the true solution. Now we have some sand granules. We are having some chalk, powdered chalk, and we are having some soil also. Look at here, this is some soil. So we'll require all these chemicals to prepare some the suspension, and also we are having the starch to prepare the colloidal solution. So one by one we will prepare the different kinds of solutions. So first of all, we'll take some amount of salt in a test tube, a little amount of salt, and we'll add some amount of water on it, and then we shake vigorously. We'll shake it vigorously. And you can see that the particles of salt get dissolved on it. Look at here, they are dissolved on it. Second is, it is sugar, and we can prepare the sugar solution also, and it is a kind of a true solution. Once again, we have taken some amount of sugar and we will dissolve it in water. We will shake it vigorously. You can see here, it forms a transparent solution. Next is the alum. This is alum. Once again, we'll take one test tube. We'll add some amount of alum on it. This is potassium sulfate. And then we'll add some amount of water on it. Once again, we'll shake it vigorously. And you will see that it forms a transparent clear solution. This is also a transparent clear solution. So in all these three cases, you can see the transparent clear solution is prepared. So these are the example of true solution. Now we are going to prepare suspension by adding this sand. This is fine sand particles. We'll add some amount of sand, and then we'll add some amount of water on it. We'll shake it vigorously, and you can see that the sand particle does not dissolve on it. They get settled down at the bottom of this test tube. So this is a suspension. Next is, once again we'll take one test tube and we'll add some amount of chalk powder on it. This is chalk powder, and we'll dissolve it with water. We'll shake it vigorously, and finally we'll see that all the chalk powder gets settled down at the bottom of this test tube. So once again, this is a kind of a suspension. Next, we'll take the third test tube, we'll add some amount of soil on it, and then we'll add some amount of water. Once again, we'll shake it vigorously, leave the content for some time, all the particles get settled down. That means this is also a kind of suspension. In the third case, so as you can see here, these are the example of true solution, and these three are the example of the suspension. Now the third is the colloidal solution. To prepare the colloidal solution, we need starch. So we'll take the solid starch in a beaker, and we'll prepare a fine paste by adding some amount of water on it. We need glass rod to dissolve it. We'll mix it, and then we need hot water, boiled water. Boiled water. So this is the starch paste. We have prepared a thin paste of starch. Then we will take one test tube, and this is a hot water This is hot water, we'll add some amount of hot water and then we'll add this thin paste of starch on it. And now we will shake it vigorously and you can see here a colloidal solution is prepared. And in this colloidal solution you can see the particle does not get settled down because this is a colloidal solution. It has the property between the true solution and suspension. So what is the difference between these three solutions? In the case of true solution, the particle size is less than 1 nanometer. In the case of colloidal solution, the particle size is between 1 nanometer to 100 nanometer. And in the case of suspension, the particle size is more than 100 nanometer. So as you can see here, in true solution particle size are so small, 1 nanometer, which cannot be seen by the naked eyes. In colloidal solution the particle size is 1 nanometer to 100 nanometer, and in suspension it is more than 100 nanometer. So as you can see here, in these solutions, these are the true solution, the particle size are so small so that it cannot be seen by the naked eyes. In the second case, in the case of suspension, the particle size are so bigger which can be seen by the naked eyes because it is more than 100 nanometers. And in the case of colloidal solution, the particle size is between 1 nanometer to 100 nanometers so that it can scatter a beam of light. Now look at here, if we will compare it on the basis of transparency, so true solutions they are transparent. If we will compare it with the suspension, so suspensions they are not transparent, and in the case of this colloidal solution it is also not transparent. Next is the filtration criteria. If we will filter the true solution, so there is no residue left, and in the case of suspension the residue is formed because the particle size is bigger in it. And the third is the stability. So the true solution it is stable in nature, in suspension it is not stable in nature, whereas this colloidal solution this is also stable in nature. So there are few criteria on the basis of which we can differentiate the true solution, suspension and colloidal solution. The first is the true solution are transparent. It cannot scatter the beam of light, means does not show the Tyndall effect. The suspension, it has a bigger particle size, so that is it can scatter the beam of light, that means it can show the Tyndall effect. And the colloidal solution can also show the Tyndall effect, that means it can scatter the beam of light. Second, on filtration there is no residue in the case of true solution, but there is a residue in the case of suspension, and once again there is no residue in the case of colloidal solution. And the third criteria, if you will see the stability of this colloidal solution, so it is stable. That means actually if you will compare the heterogeneity, so the true solution they are homogeneous, and the suspension and colloidal solution they are heterogeneous. And very specific thing about the colloidal solution, it looks like a homogeneous but actually it is a heterogeneous solution. Thank you.